In this lecture, we will talk about applications of base change formulas. See, this is the formula. This one says that log base b to the u equals log base a to the u divided by log base a to the b. Here a are the same. Okay. So a can be 10. If a is 10, you don't need to write 10 as a base. That will be log u divided by log b. A can be e also. If it's e, then log base e, you just simplify that to write ln natural log u natural log b. Okay, that's the formula. So you see, from the left hand side, you don't have a, but right hand side, a can be 10, can be e, can be anything. So you actually can add a base. Depends on your need. Okay, now let's solve those equations. Find exact solutions for the following equations. There are 3 equations right here. Let's look at the first one. The first one says that 4 to the x equals 6. So you may rewrite this one by definition. Okay, by definition, that the above equation can be written as what? A log is used to find out exponent. Exponent of 4. Okay, so basically you can express x as log base 4 to the 6. Yeah. And then use the base change formula. Then you can write log 6 divided by log 4. Basically, this is the formula. You see, log base 4 to the 6 equals log base a to the 6 divided by log base a to the 4. If a is 10, that's the one you wanted. If a is e, and this is the one you wanted. Log, natural log 6 divided by natural log 4. Okay. Again, are those two the same? You can see. Turn on your calculator, and you may type natural log 6 divided by natural, here is not natural log, base 10. Yeah, so log 4. You hit enter, you have 1.292. If you are required to have only 2 digits after the decimal point, then you only need to look at one more digit, the third one. Since here the third one is 2 less than 5, 2 is less than 5, you drop it. You drop this 2. So that's 1.29. That's the approximation, okay, of this answer. You can also use natural log 6 divided by natural log 4. You will end up with the same answer. You see here, natural log 6 divided by natural log 4. Hit enter. The answer is the same. That's question 1, easy one. Question 2, your exponent is 4 minus x. This one looks complicated. But you know, by definition, you can rewrite 4 minus x is the exponent. Okay, my logarithm function, that's log base 3 to the 5 equals the exponent 4 minus x. Okay, remember the logarithm is always used to find out the exponent, to find out 4 minus x. Okay, exponent of what? 3. 3 here is the base, 3 here is also the base. Okay, and 4 minus x was the exponent of 3. So log base 3 to the 5th equals 4 minus x. Okay, yeah, because here 4 minus x was the exponent of 3. 3 to 4 minus x, the exponent, was equal to 5. Okay, now you want to isolate x. So minus 4 on both sides, you cancel positive negative 4. Left hand side you have a negative x left. Right hand side is log base 3 to the 5 minus 4. Okay, now here's negative x. Then both sides needs to be multiplied by negative 1, because negative times negative you are positive. Right hand side was log base 3 to the 5 minus 4 times negative 1, then negative 4 times negative 1 is positive 4. Negative 1 times positive log base 3 to the 5, that's that. Okay, yeah, this is the exact solution. Yeah, here was the exact solution. But in order to find out the approximation, you need to change the base. Okay, yeah, right here then you can see we didn't do anything with 4, we keep it. And then here we change log base 3 to the 5 to natural log 5 divided by natural log 3. Okay, and the 4 we keep it. Natural log 5 minus over natural log 3 approximately is this number. You see, natural log 5 divided by natural log 3. You hit enter. 1.4649. 1.4649. Here, remember, if the final answer requires us to keep 2 decimal places after the decimal point, you always want to have a 1 more digit. Okay, so you want to keep the 3rd digit after the decimal point for the middle process. If you skip 1 more digit in the 3rd place, you're going to get the wrong answer. Okay, let me repeat here. If you need 2 digits after the decimal point, then during the middle step, you always want to keep the 3 digits after the decimal point. 1 more than required for the middle steps, in the middle steps. Okay, and then 4 minus 1.465, that equals 2.535, and approximately it's 2.54 because you round this 5 up. Okay, 5 is greater than is 5 or greater, then you want to round it up, so 2.54. Okay, so don't do this one right in the middle. Look, this is, by the way, we are done, and this is the correct answer. Okay, but if you drop this 5 in the middle step, you are going to get a wrong answer. Okay, so that's why it is important to keep 3 digits. If you only need 2, if you need 2 near the end, you must keep 3 digits. Okay, otherwise you will get the wrong answer. For example, here if you drop 5, then 4 minus 1.46, here you will have a 4. Okay, 5, 4, 2.54. Yeah, and yeah, in this case is okay. Yeah, in this case is okay. So 2.54. Okay, so remember here they must keep 3 digits if there are only 2 digits required. Okay, that's for question 2. Question 3 is a little bit more complicated. That's 3 to the x plus 1 equals 2 to the 2 minus 3x. The typical way to solve the exponential equations is choose the logarithm function on both sides. Okay, so here we said choose both sides, choose log. That's the technique. Okay, you may choose natural log, or you may choose log base 10. Here we choose log base 10. Okay. Now, if you choose log on both sides, then you can take this exponent down to the front. That's x plus 1. Down to the front means x plus 1 times log base 3. Okay. Take this 2 minus 3x down to the front. That's 2 minus 3x times log base 2. Now, since these are multiplications, by using the distributive property, log 3 times x, so you have that. And then log 3 times 1, you then have that. Okay, 1 times log 3 is log 3. 2 times log 2, that's 2 log 2. Negative 3x times log 2, that's negative 3 log 2 and then x. Okay. Now you want to isolate x. There are 2 terms with x. So you wanted to put those 2 together. So you plus 3 log 2x, that's the same with the one above, because you want to cancel that. And the left-hand side, you do the same thing. Okay. So you then have a 3 times log 2x, both sides add the same term. So right-hand side, you cancel these 2, positive, negative. You have a 2 log 2 left. But remember, 2 is right before, in front of log 2. These 2 can be brought to the exponent of 2. That's what I did here. So right-hand side, it has 2. It has log 2 to the 2, because you bring this coefficient. That's the multiplication again. Here is multiplication. All right. So you bring these 2 to the top. You have these 2. Now left-hand side, you have those 2 terms. So you put together. Okay. Log 3x. That's here, and here is 3 log 2. And then x is right here. And there was a log 3, so you leave it. Okay. Now you have x here, you can pull x out. That's right here. Okay? And then these 3 can be brought to the exponent place of 2. So after you pull x out, first one is just log 3. The second one you brought these 3 to the top, okay, as an exponent. That will be 2 cubed. We know 2 cubed is 8. So that's for those 2 tens. Okay. Now for this one, log 3, you want to do is minus log 3 on both sides. You may then cancel these 2, positive, negative. So left hand side does not have a log 3. So it only has those 2 combined. Right hand side, you minus log 3. Then you keep it minus log 3. And here log 2 squared is 4. Okay. Again, left hand side, those 2 are cancelled. You only have these 2, which end up like that. So right hand side is log 4, because that's 2 squared, minus log 3. Again, why do we need to square? 2 is brought up. Okay, that's we said before. Now we have a left hand side, x times this one. Okay, right hand side we have a log 4 minus log 3. Right hand side is subtraction, so that will be log 4 divided by 3. Subtraction comes to be division. That's right hand side. Left hand side, you have the coefficient of x, which is plus between those 2. We know 2 cubed again is 8. Here is plus, so then you have a multiplication. So 3 times 8, which gives you 24 right here. Okay, now again here is multiplication relationship. So then you will have both sides divided by log 24, because 3 times 8 is 24. And the right hand side also divided by log 24. So you may then cancel this one are the same. Okay, because log 24 divided by log 24 is 1. 1 times x is just x. Right hand side, you then have a log 4 over 3 divided by log 24. And that's the exact solution. Okay? Please review these 3 examples. I'll see you next time.